Assalamualaikum warahmatullahi wabarakatuh to Madam Basira. Today our group, which is group 6, will present about the production of benzene. So this is our group members. Firstly, Rahman Hamimi, then Izlan, next Zarif Azim, and the last one is Tariq Baik. Assalamualaikum warahmatullahi wabarakatuh. My name is Izlan bin Johari and I will present about introduction. First of all is benzene. So what is benzene? Benzene is a chemical that is colorless or light yellow liquid at room temperature. It has a sweet odor and is highly flammable. Also that benzene evaporates into the air very quickly. Its vapor is heavier than air and may sink into low-lying areas. Not to forget, benzene dissolves only slightly in water and will float on top. The advantage of benzene is to create other substances that are then used to create synthetic fiber, nylon as well as plastic. However, benzene also have disadvantage that cause harmful like a decrease in red blood cells. Then is toluene. So what is toluene? Toluene is a clear, colorless, volatile liquid and smell odor. It is a flammable at temperature greater than 40 degrees Fahrenheit. Toluene mixes with many organic solvents but is poorly soluble in water. Toluene is less density than water and will float on the surface of water. The advantage of toluene is used to make other fuel like gasoline, paint, patina, rubber and adhesive all employ toluene as a primary ingredient. For the disadvantage, toluene make eye and nose irritation, tiredness, confusion, dizziness, and headache. Next, for chemical properties, the chemical properties for benzene and toluene. For chemical formula, benzene is C6H6, while toluene C7H8. Toluene has higher boiling point than benzene. Also, toluene has higher melting point than benzene. The density for both is equal. Toluene has higher molar mass than benzene. For solubility, benzene is soluble in alcohol diethyl ether and acetone. After that, benzene is created by the hydrodealkylation of toluene. In this procedure, the primary response is toluene plus H2 to benzene plus CH4. Benzene and methane are created when toluene and hydrogen are transformed in a reactor that is loaded with catalyst. Usually, the conversion rate of the reaction is 90%. In that case, the reaction is extremely exothermic, and the usual work range are 20 to 60 bar and 500 to 660 degrees Celsius. That's all from me. Next, I will pass this presentation to the next person.
Assalamualaikum. My name is Muhammad Hussein bin Kamur Zaman, and I'm going to present about the drawing and the commands as well as function of each component in the process flow diagram. The application used for drawing in this process flow diagram is AutoCAD, and the commands used for drawing the diagram are the lines that used to draw the box, connecting the components, and a bit on heat exchangers and at distillation column. The circle is for drawing the pumps and heat exchangers, the field for creating rounded edges between the adjacent lines for vessels, and the multiline for the phase separators. For the symbols, the input and output used for denoting program input and outputs. The stream identification is used for identify streams on the process flow diagram. The gate valve is for represents a linear motion isolation valve and has a function to stop or allow the flow. Next, the vessel in this production is a container that is used for storing the product. The pump is to accelerate the separate components of a mixture on the base of the density, size, viscosity, and rotor speed. This function of this pump is the same as the compressor. The heat exchanger is for transferring heat between two or more fluids that separated by a solid wall, and the fired heater is for raising the temperature of the process fluid that flows through the tubes. The pad column is used for distillation, gas absorption, and liquid-to-liquid extraction, and the turbine is for converting the available energy into the fluid that enters it to generate electrical energy. Then the phase separator is used for separate produce well fluid into gas, oil and water phases by using gravity. Lastly, the distillation column in this production is where the condensations and vaporizations processes can occur. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rahman Hamimi and I will present to you about the process of the production of benzene. First of all, the process starts with the preparation of reactor feed. So, 108.7 kmol per hour of fresh toluene stream at 25 degrees Celsius and 1.9 bar of pressure is mixed with a recycled toluene stream at 112 degrees Celsius and 2.43 bar of pressure into a storage tank. Then toluene is pumped through a pump which is discharged at 25.5 bar pressure into another storage tank. In the tank, the mixture is blended with a stream of both fresh and recycled hydrogen. Then the two-phase stream will be heated until toluene vaporized to become a one-phase stream. The stream will enter a furnace that is fueled using gas to heat up the stream up until 600 degrees Celsius. Now, the reactor feed is at an ideal condition where reaction can occur, which is at 600 degrees Celsius and a pressure of 24.81 bar. Next, in the reactor, the stream is fed into a reactor that is filled with catalyst. As the picture shown, toluene plus hydrogen is equal to benzene plus methane. So, hydrogen is injected to regulate the temperature of the exothermic reaction. When leaving the reactor, there are methane, benzene, toluene, and hydrogen that are present in the stream. Around 75% of conversion are usually made in one pass. Then, the stream enters a heat exchanger which cools down the stream using cooling water. Mostly, toluene and benzene in the product stream condenses when entering the heat exchanger that cools down the stream to 38 degrees Celsius. In the separation stage, the two-phase stream that contains benzene, methane, hydrogen and toluene is fed into a high-pressure phase separator. The liquid and vapor are divided. So, in the upper atmosphere, methane and hydrogen are present, which are the principal gases, while at the main exit of the separator, which is at the lower atmosphere, departs benzene and toluene. The overhead stream is divided into two streams, which is a portion of the fuel gas stream and a stream that has been compressed in a compressor that is recycled back to the feed and reactor. For the second separator, it is used to complete the partially separation from before. This separator separates the methane and hydrogen mostly in the overhead system. This separator operates at low pressure. The liquid consists mostly toluene and benzene with traces of dissolved hydrogen and methane. Then the stream is heated in the heat exchanger before entering the distillation column. The heat exchanger uses low pressure steam to heat the temperature of the stream. And last of all, at the distillation column, toluene leaves in a form of liquid. The overhead condenses at a temperature of 112 degrees Celsius that contains benzene, traces of hydrogen and methane. The vapor leaving the column is condensed using a cooling liquid. The remaining hydrogen and methane are then separated and the vapor stream then joined with the overhead gases stream from the first and second separator that creates the gas fuel. The leaving stream, which is in a liquid form, are pumped using a pumping stream that creates two streams. Both of the stream then enters a heat exchanger. One of the stream is cooled until 38 degrees Celsius while the other one is fed into one of the columns. The product stream is then transferred into the storage after cooling down. Thus, the production of benzene is completed.
Thank you, Rahman. Assalamualaikum. My name is Tariba and I would like to present about the conclusion. To conclude, Benzene was considered the widely utilized feedstock for the production with no substitute in the synthesis of polymer with and high energy density liquid fuels. The capacity to create benzene renewably from sustainable carbon feedstock is essential for a future circular economy. Consumption of benzene, which is derived from fossil carbon, leads to growing atmospheric CO2 level near the end of life. This problem comes from benzene production that is widely used in the United States, as it ranks in the top 20 chemicals for production volume. The annual production of benzene is shown in the chart below, which is the annual production of benzene in the world is 46 million tons. In China, the amount produced is 11.9 million tons. In Japan, it is 9.5 million tons, and South Korea is 6.9 million tons. Europe is 6.8 million tons. United States is 3.8 million tons, and lastly in Germany is 2.4 million tons. Lastly, for the recommendation part, although benzene has many negative impacts on health and the environment, it nevertheless has many benefits. For example, certain businesses utilize benzene to manufacture other compounds that are used to make plastics, resin, nylons, and synthetic fibers. Some lubricant, rubbers, dyes, detergents, medicine, and insecticides are also made from benzene. So in order to manufacture high-quality benzene, an urgent approach is required since developing technologies show that renewable benzene that may be produced from a range of catalysts and feedstock. However, this approach are immature, having just been created in the previous 2 decades. It is obvious that benzene will not be generated in isolation, at least not with the current catalyst research lines, but rather as a part of a larger biorefinery generating a range of hydrocarbons or aromatics. The rapid rate of development and diverse range of technologies investigated underline the difficulties of the situation. When should corporations spend in installing a promising technology if low maturity catalysts or pathways with better conversions and cheaper costs are on the horizon? That's all from us. Thanks for watching.